Chapter 11, Section 6, volumes of prisms and cylinders. Volumes instead of surface area. The volume of a cube, perfect cube, is side cubed, because you're going to take the side times the side times the side. You've possibly heard of volume before as length times width times height. Well, as you know, we don't talk about length and width anymore. We talk about base and height. But in a cube, whether it's the length, the width, or the height, they're all the same size. So you just take the one measurement of the side and cube it. Any prism, no matter what, you're going to take capital B times H. Capital B times H, I'm going to get these out. And capital B, yes, you have to write it as a capital B, because capital B stands for the area of the base. The area of the base. So if you have this prism, take a look at this prism, and it is a triangle. I'm trying to hold it so that you can see through it. It is a triangle, so you would have to find the area of this triangle and take it times the height. And remember, we've talked about height before. If you're laying down, you're still the same size. So the height is the distance between the two bases. Whether you hold it like this or if you hold it like this is still the height. So capital B is area of the base. So in this case, you have to find the area of an equilateral triangle. In this case, you have to find the area of a rectangle and then multiply it times its height. In this case, you would have to find the area of a hexagon, regular hexagon, and then multiply it times its height. There's a lot of them. Well, here would be your cube. You could do the same, area of the square times its height. But area of its square times its height, the area of the square and the height are all going to be the same, which is why we could do s cubed. Okay, let's practice some of those. And then we'll do the area of the cylinder, area, we're on to volume. Volume of the cylinder is pi r squared times h. Now let's think about that. Pi r squared times h. Pi r squared is capital B anytime that you have a circle. So if you're talking about a cylinder, we've got pi r squared, area of the base, times the height. But because all circles and all cylinders have the same shape as their base, you can just say pi r squared. You don't have to change the capital B. So here it is. We'll start with the cube. You shouldn't have to draw this if you have a handout. If you don't have a handout, you're going to have to pause it and draw it. You've got a cube with side of 4. That means it's 4 by 4 by 4. Everywhere around is 4. And you would take 4 cubed. 4 times 4 times 4 is 64. And be careful now on our units. We're going cubic centimeters. 4 centimeters times centimeters times centimeters is 64 cubic centimeters. Take a look at this rectangular prism. If we want to take the area of the base, volume equals capital B times H. But our capital B in this case is base times height of the base and then height of the actual prism. Well, what's our base? We've got a 5 by, if this is 4, this is 4. Our base is 5 inches by 4 inches. And the height, or the distance between the two bases, is 3. Multiply those together, your volume is 60 cubic inches. But now think about that. What if you were holding this prism the way that one was, like this? You're holding the prism like this, and you're like, I took the area of this base down at the bottom, 4 by 3, or 4 by 5, and I found the height of 3. But if somebody else wants to hold their prism like this, now this is their base. And somebody else says, no, I'm going to hold my prism like this. Now this is their base. Their base is going to change depending on how they hold it. But should that change the volume? That shouldn't change how much space this takes up or how much you can pour into it. The volume shouldn't change. So if somebody else took this same diagram and said, nope, I'm going to use this as my base. 4 by 3. That's my base because I'm going to turn it sideways. Then you would take 4 by 3. But the height would then be 5. the distance between the two bases. So you'd end up with 60 cubic inches. And then your third person says, no, that's not the base. My base is, what else would I put it? Right here in the front. This is my base. I'm going to have the front and the back be my base. Okay, front and the back, that would be 5 by 3, takes up 15 square inches. But then the height is the distance between those. 5 times 3 is 15. 15 times 4 is still 60 cubic inches. So don't fight over where the base is, as long as you do the height between the two bases. Let's try it with a triangular prism, but it is not an equilateral triangle, as you can see. It's scalene triangle. Looks equilateral, it's almost drawn, but it's 3, 4, 5, and the height is 7. So we have to find capital B, which is the area of the base, as 1/2 base times height, times H, which is the height of the entire prism. We already know that is 7. Half the base times the height. Be careful on this one. Too many say that the base is the bottom, and then you would take this 5, and then you would try to cut it in half, and then you'd make this 2.5, and then you would do the Pythagorean theorem. Yeah, you'd get there, and you'd find the height of this triangle. But remember, base times height of a triangle are perpendicular, and you already have a right triangle. Just spin it that way. This is the base, this is the height. These are congruent up here, so they have to be the same. So I can do half base times height as 1/2 times 3 times 4. Base times height. What's the height of the entire prism? 7. Half of 3 times 4 times 7 is 42 cubic feet. This time we do have an equilateral triangle. It's 6 by 6 by 6. You've got tick marks on each one. Height is 12. We need 1/2 base times height times the height of the prism. Actually, don't let me get ahead of myself. We need capital B times H for volume. But our capital B is 1/2 base times height because it's an equilateral triangle. We know the base of this guy is 6 because it's 6 by 6 by 6. We know that half of its base is 3. Half the base is 3. The height of this triangle, it's a 30, 60, 90 is 3 square root of 3. And the height of the entire prism is 12. And yes, we're going to go ahead with an exact answer and an approximate answer. 3 times 3 times 12 is 72. 72 square root of 3 cubic inches. What is that approximately? You would need a calculator for that. I'm going to take 3 times square root of 3 times 12 and find out that that's approximately 187.1. I took 3 times 3 times 12 times square root of 3. Now I'm going to take 72 square root of 3 just to check my answer, and that didn't work. 72 times square root of 3. That's because 3 times 3 times 12 is not 72. You got to be more careful than that. 3 times 3 times 12 is 108. Had I not checked my answer, I would not have known that. 108 square root of 3. So if I take 108 times the square root of 3, I get 187.1. So why did I do that? Because I had to check my math. I took 3 times 3 is 6, times 12 is 72, which was wrong. 3 times 3 is 9, times 12 is 108 square root of 3. When I checked in my actual answer, or my approximate answer, I went back up to here, which was the original, instead of using my false answer. Always good to double check. All right, and my cylinder, we'll do one cylinder. We'll do two cylinders. This one is drawn for you. Volume of a cylinder is still capital B times H, but our capital B is pi r squared. Pi times 6 squared times 8. Exact answer first. 6 squared times 8 is 288 pi meters cubed. Approximate answer, what is 288 times pi? 904.8 cubic meters. Lastly, can you draw this just for fun? Draw a hexagonal prism with sides of 10 and a height of 15. How do you draw a hexagonal prism? You draw a hexagon, but your hexagon, because you're going three-dimensional, you don't want to draw it as a perfect, like, big old hexagon. Because if you look at something, look at that, that's a pretty good hexagon. Stuck out a little here. If you're going three-dimensional, you kind of want to squish your base a little bit. If you look at my cylinder, that's not a circle. If you took out the three-dimensional aspect of this, that definitely is not a circle. It's an oval. So you don't want to draw a perfect hexagon. You're going to want to draw it a little bit flatter. So if I can draw this, you'll be told that it's a regular hexagon. Then try to draw one exactly like it. If you could draw one exactly like it, I'm going to clone it and cheat. Straight above it, all you need to do then is connect the vertices. Connect that side, connect that side, connect that, connect that. We've got all the ones in the front. If you want to do the ones in the back, I don't know, maybe do you want those dotted? We could do those dotted. And there's your hexagon. Sides of 10, height of 15. And that works to draw pretty much any three-dimensional figure like that. That's it.